everyone. We are starting our chapter 1 for everyday chemistry, and on the top we'll have all the things that would be covered in this note. With chemistry, there's always some math that's involved because chemistry is a science that is based on quantitative observations or measurements. But let's go through just the chemistry part first. Everything that you do around you involves some kind of chemistry. When you cook, when you combine metals together, even when people start to extract compounds from different types of plants like aloe, those things are all parts of chemistry. And so you can see here chemistry takes central role in terms of its relationship with all these other branches of science. Now, the knowledge that we learn in chemistry relies on this process called the scientific method. This is a diagram that shows how the scientific method works. It all starts with this part right here, which is an observation. Why is the sky blue? Why does this particular plant work when I take it for my cold? And that becomes your observation, and then you start to form a guess as to what the reason is. So once you have that guess or hypothesis, you then have to test the hypothesis by performing an experiment. Let's say you take a plant and it cures your fever. You may say that, well, in that plant there is a compound that would help to cure fever. So then your experiment has to be to isolate that compound. And then you have to test it to make sure that it does cure fever. So that is the cycle that you would have to do. And let's say the compound you tried didn't really work out, then you can say, oh, maybe there's another compound in the plant because the plant is a pretty complex organism. So you would go through this cycle of making a guess, testing your guess, and then if the guess is wrong, you do another guess. So that just keeps going on and on. And then once you find something that works, then you would share that information with everybody else. If other people test it and get the same results, then that hypothesis that you've formulated at the beginning now becomes what we call a theory. So a theory here means something really strong. It's something that people have tested for many times. Now, there's another term that we use in the scientific method called a scientific law. And this is just an observation that people have seen again and again and again over time. This is different than a theory because it's not an explanation, it's just an observation. Once we have the theory and the law is when we actually say, okay, now we know something pretty well. That whole process here from the left to the right could take many years. In chemistry, what we study is something called matter. And matter is everything that is around us except for light. The air around you, the table that you have your computer on, the water or soda that you drink while you're listening to the video. All of these are examples of matter. So just as the examples I mentioned there, there's 3 states of matter: solid, a liquid, and a gas. Solid, they have a fixed shape. It doesn't change the shape, and the volume also doesn't change. Okay, you can take this cube of ice, for example, and pour it from this flask into a cup. It will look exactly the same. A liquid changes its shape according to the container that you put it in. So for example, if I take this liquid and I pour it out to a cup that has a different shape than this flask, then it will assume the shape of that cup. With liquid, it just fills some part of it up to the volume of the liquid. But with gas, if you even put a little bit of gas, it will automatically just spread over and fill up the entire space. The gas particles will expand to all the space that's available to it. Now, I just said the word particle. When we look at these things with our eyes, we see them looking as shown in this top picture right here. But in truth, each one of these objects that we see is actually made up of what we call atoms. Atoms is a tiny little marble. That's the best way to kind of think about it. Now, how the atoms are arranged is what makes them look different to us by our eyes. So for like a solid, the atoms are all packed tightly together. And so this is what we call a crystal. And so this would appear to us looking like the solid or this ice cube. Now, of course, the atom is really tiny. We can't really see them by our naked eyes, but there are experiments you can do that will show you exactly how the atoms are arranged. Liquids must have a different atomic structure. They're separated further away, and also they're free to move around. They're still somewhat touching each other, but they're just not touching each other in a fixed shape like the solid. Now the gases, they're just independent of each other. If you think about a big open space where people live really far away from each other, that's what a gas is. So you can't even see where your neighbor's house is because they're so far away from you. With a liquid, you can see your neighbor's house, but you have plenty of space. With a solid, it's like you're living in an apartment building. Everybody's packed next to each other. In addition to knowing the states, we also need to know that there are different ways matter is composed. Composition of matter affects its properties. So the first thing to think about is there's two types of ways we divide matter. Something called a pure substance and something called a mixture. I'm going to have some pictures here to show you. So a pure substance is a sample that only has one thing in it. So for example, like pure water, that's a pure substance. Pure chlorine gas is a pure substance. It only has chlorine in it, doesn't have anything else. Now, a mixture, as you might imagine, is just a mixture of some of these pure substances. So the soda you're drinking while you're listening to this video, that's a mixture. There's water for sure, but there's sugar, there's salt, there is some carbon dioxide gas that's dissolved in it to make it fizzy. So that's what a mixture is. So that's the main difference between pure substance and mixture. And then pure substance themselves can be divided into what we call element versus compound. So element just means that they are formed by just one type of atoms. You will learn later on that there's a number of elements that we know of on Earth. For example, iron is an element, oxygen is an element, helium is an element. If your pure substance is only made up of the atoms of that one element, then it's called an element. For example, here we have zinc and chlorine gas. So zinc is made up of just atoms of zinc, which is these green little marbles, whereas chlorine gas is made up by two of these chlorine atoms that are stuck together. So they're called molecular elements because two of them are stuck together, but it's still of the same element. If your pure substance is made up by two or more elements, then it's called a compound. So water is a compound. Why is that? Because you have two different elements in it, hydrogen and oxygen. So the hydrogen is the red stuff here, and then the oxygen is the green one. So its formula, as you'll learn in a second, it's called H2O. That means there's two hydrogen and one oxygen in water. You can mix any combination of element and compound to give you a mixture. We still are differentiating in mixtures though, because there's what we call heterogeneous versus homogeneous mixtures. Heterogeneous mixtures are mixtures where the two different things that are in it can be observed using your eyes. So for example, when you mix oil and water, you can see that a layer of oil and layer of water. Whereas homogeneous mixture are mixtures when you mix them together, you can't really tell the difference. So for example, here is some salt that I pour into this cup. Once I mix it, the whole thing just looks like clear water. The only time I would know that there's actually salt in it is when I take a sip of that water. Basically, the main difference microscopically when you look at the level of the atoms is that with heterogeneous, things tend to clump together. So for example, this one has two different elements that are mixed together, but the pink ones are kind of clumping on the top, and then the red ones are clumping or grouping at the bottom. With this one, the blue ones are kind of clumping in the middle, the white ones are around the outside. Homogeneous mixture, the difference is that they are not clumping, so they're spread evenly across the entire space. Here's a good example of it. The red and blue are just kind of spread around, so some red, some blue, unlike this one where the blue is all in the middle and then the white's all around the outside. Now, I just mentioned about atoms and molecules. So what are they? An atom is just the smallest particle of an element that has the properties of that element. We use the word particle to represent a lot of different types of chemical species, like an atom, an ion, even like subatomic particles like these protons, neutrons, electrons. We can call them particles as well. How do we know that we have atoms? Well, because we can actually do experiments to look at them. Okay, so here's a sample of gold. When you actually shine X-rays on them, you can actually see the individual gold atoms. Now, the atom themselves are made up of subatomic particles. So the word sub here just means they're smaller. There are three of them, protons, neutrons, electrons. So every atom has these three particles. The protons and the neutrons are stuck together, and they are at the center of the atom, called the nucleus. And then the rest of them are just electrons. This green one, they're smaller than both of these guys, moving around constantly around the atom. They're stuck in a vicinity of the nucleus because these subatomic particles have different charges. So protons are positively charged, neutrons have no charge, and then electrons are negatively charged. And humans have known for a long time something called the electrostatic law, which is that when you have two things that are the same charges, so positive, positive, or negative, negative, they're going to repel. Whereas opposite charges attract. And there are experiments you can do. You can rub wool with particular material like plastic, and then you'll see that it will repel pieces of paper. Sometimes it would attract hair. So the protons are positive, the electrons are negative. That's the reason why the electrons are kept around in the atom. They can't really escape. If all our world is just made up of these atoms of specific elements, they're not going to be that interesting because there's not that many of them. Now, what makes them really interesting is you can take one atom of one element and then combine them with an atom of another element to make them into what we call molecules. So molecules are two or more atoms that are joined by forces that we call chemical bonds. These chemical bonds are just these electrostatic force. So you have a positive on one side, you have a negative on the other side, and they're stuck together like glue. And so those atoms then combine together and they form these molecules. Water is a molecule. There's two atoms of hydrogen, which is the red stuff, and then the green stuff is the hydrogen. And so they're stuck together. Why? Because there's electrostatic interaction between the green atom, which is your oxygen, and then the two red atoms, which are the hydrogen atoms. Necklaces, they're connected together. That's a good analogy for chemical bonds. We don't always want to draw out these little circles to represent our atoms. It's kind of cumbersome. So we have symbols to represent how a substance is made up. So we use numbers written as subscripts to represent the chemical formula. So for example, hydrogen is a gas. It's made up by this element that has a symbol H, but there's two of them bonded together by the chemical bonds that I just mentioned. So we write the formula H2. The 2 is written as a subscript. Oxygen, same thing. Two of the oxygen atoms are stuck together by this chemical bond, and we write it as O2. Phosphorus, interesting. Not just two, but there's 4 of them stuck together, and so we write it as P4. Water, as I mentioned earlier, is H2O. 2 hydrogens, which is the white spheres, and then the oxygen is red. Now, sometimes we don't want to just write H2O like this, so sometimes we might write it out this way with a little line connecting the O and the H. That just tells you that there's a bond. So the line represents a bond. So we call this the structural formula because it actually shows you how things are connected together. We can actually build models. They come in these forms of spheres and then these little connectors. So we call this the ball and stick model. If you're on campus taking this class, you'll have access to these model kits that you can use to build your own model of water. And then we have computer programs that could illustrate the actual drawing. So that's what we call the space filling model. Here's just another example of another molecule called methane. It's actually the gas that you use at home to cook, to heat your water, and to heat your house in the winter. Natural gas is methane. It has a formula CH4. Well, that means there's one C atom, which is carbon, and then there's 4 H atoms, which is hydrogen, and they're all connected together. How are they connected? Well, here's the structural drawing. It shows that carbon is in the middle, and then there are 4 bonds to the hydrogen from the carbon. This structural drawing helps you visualize what the molecule actually looks like. But this alone doesn't actually tell you what it looks like in 3 dimensions, but when you build that ball and stick model, you see that it actually forms this structure, which is something we call a tetrahedral structure. And then this is the space filling model. This is what you expect to see in real life. Okay?